Yeah, well, thanks very much for the opportunity to showcase some of this new technology, innovations and operating practices for New Zealand harvesting operations. This is the first successful project that's come out of the PGP program in forestry automation and robotics, which is managed by Forest Growers Research. The project is co-funded by MPI, Ministry for Primary Industries, the Forest Grower Levy Trust, forestry companies in New Zealand, and the manufacturing partners are Rosewarne and May. So a little bit about Rosewarne and May, a little bit of background. That company is the design and manufacturing division of the Rosewarne group of companies that's based up in the Northland region. Rosewarne and May developed the ROB or ROB, Remote Operated Bulldozer Winch Assist System, back in probably about 2014, so they've been doing that for about 7 years now. Sold now about 34 of those units, and mostly into Canada. The directors are Lars Rosewarne, it's a well-known character in the New Zealand logging industry, and Ian May, and Ian's the engineering side of the business, and Lars is the logging side. So the other company that's involved is Rosewarne Cable Loggers, which is a large contractor in the Northland region, contracting to Hancock Forest Management and Rainier Matariki Forests. So what was the project about? The drivers were really to resolve a lot of the issues that are associated with existing hydraulic grapple carriages. To deliver the efficiencies for tower, probably about two towers to one swing yarder, something of that nature, to increase the use of grapple carriage systems so that obviously automating the extraction phase and increasing utilisation of those systems. Obviously, using a grapple, you're improving health and safety, removing manual breaker outs from the risk, and also from an automation point of view, one of the drivers was really to try and reduce the workload on the hauler operator so that he has a bit more sort of job satisfaction. So let's have a listen to Lars. He's obviously the instigator or the originator of the project as to why he wanted to develop the integrated carriage and hauler system.
We've always run towers, and this machine, it's actually preset at 23 tonne, or you can preset it at 19 tonne, so you can never ever overload it. Now we can walk away and we don't have to worry of drivers overloading and smashing skylines and that type of thing. You smash a skyline, the carriage is going to only go one way, and that's to the ground. And when you've invested, $180,000 into a carriage, the guy gets it wrong, you're going to reinvest very shortly. The insurance companies won't insure them if they keep hitting the ground. And like I say, with this system, you can't physically damage that carriage, not unless you pull it into something. So that was the main reason for us to head down that track, hydrostatic, the skyline.
So yeah, the objectives were to design, develop, manufacture and commercialise a semi-automated tower yarder with an integrated grapple carriage. The Thunderbird TTY70 tracked hauler was the base machine for the prototype, and the features include the hydraulic skyline control, which Ian will be giving us a bit of a detail about shortly. Sensors for collision avoidance during normal operating conditions, integration of a new type of grapple using a swinging arm rather than direct connection of the grapple to the carriage, and also the opportunity to retrofit the system to other yarders with no loss of productivity during the refit through the use of using this first prototype as a swap machine for the next client. As the concept design was already undertaken by Rosewarne and May, the IP sits with them, and as I mentioned, large elements of the ROB technology were used in terms of the winch control and radio remote control. And field testing would be undertaken locally with Rosewarne cable loggers, and manufacturing meets ISO standards. So looking at the Grapple design, there's a number of key features. Rosewarne and May wanted it to be a simpler design on a swinging arm to reduce the shock damage to the carriage. They wanted to use off-the-shelf components as much as possible, and also they wanted it to be light but strong enough to handle the robust nature of the work. Looking at the project budget, that was established with 3 development stages. The stage 1 was preliminary work, stripping down and refurbishing the hauler, so we're not really going to cover too much about that this morning. Rebuilding of the second stage, rebuilding the hauler cab and the fabrication of the grapple, and we'll see the grapple working, and setup and field testing, which is the stage that we're at now. The total budget for the project was planned to be 1.125 million, but it's ended up a little bit north of that. And that's been additional work that's been done by Rosewarne and May as an in-kind contribution to the project. So looking at the development of the project, that started back in September of 2018 when Lars and Ian put a proposal to the forestry companies Hancock Forest Management and Rainier Matariki Forests. The forestry companies saw an opportunity for an industry-wide project rather than just something that was specific to them. And so they involved Forest Growers Research with the funding that's available through the Ministry for Primary Industries. So the first project meeting was held in November of 2018, and investment was agreed between the 2 forestry companies, the Ministry for Primary Industries, which is the major funder of the PGP Automation and Robotics Program, and FGR, using the Forest Grower Levy Trust funds. The design was commenced in January of 19, and the base machine was purchased in September of 2019. So now Ian will describe the work that was done to develop the hydraulic skyline control.
The most work that we had to do was to actually change the skyline. The skyline was the key part of the whole thing. So to make the skyline work, we pretty much had to pull the skyline drum out, chop the shafts. We had because the original shafts, they just had the water brakes on one side and a clutch on the other side. So basically we had to rehash the shaft. We still kept the original shaft in there, but we just chopped it and we set the shaft up in a big mill, and we milled a keyway, and we made a big spline hub to fit on there. So there's 2 spline hubs on each end for the drives. We'll show you that shortly. Second thing we had to do was hydraulics. So these machines come out with pretty good, they're a hydrostatic system, which are fairly good hydraulics. And we managed to reuse all the original hydraulic pumps and drive boxes and all that part of it, and then we had to put the hydraulic controls for the valves and all that, which we'll show you. So pretty much we do all rehash the hydraulics, and then we did the electrical system. Now the electrical system is totally, it's not a new concept, they've been out for a while, the CAN bus system, which we talked about before. Pretty much 99% of machines nowadays are built with a similar technology. Most of the excavators, airplanes have them in now, all that, and basically it's a communication network like a telephone exchange. So pretty much what it does is you have different modules or different little microcomputers between each function. So one will control all the engine management, one will control all the hydraulic management, one will control all your sensors, and one controls all the air systems, so that each of these computers are talking to themselves between each other, so they're all communicating. And it's all done through 2 wires, so there's only 2 wires that communicate between the whole lot.
So that's the, I guess, the technical detail that is way above my head, but at the end of the day, the machine's up and going, and the first operating trials were commenced in December last year at Rosewarne Cable Loggers, testing in a pretty tricky setting in Pipiwai Forest in Whangarei, extracting stems over 500 metres away. So what were some of the learnings from that first trial? The Skyline drum had plenty of power. That was the first important thing. And the drum speed appeared to be quite slow. So Rosewater May decided that change in the ratios was required to speed that up. The tension monitoring system was working well, so that was being displayed in the operator in the cab. And one of the initial or potential problems that was foreseen was line wrap between the Skyline and the main line, but that appeared not to be such a problem. Hydraulic cooling was not sufficient in their view, and they wanted to make some modifications to the cooling. From an operator perspective, looking at the control system, very visual sort of control, excellent visual alerts. The screen, the operator was able to switch between functions at the push of a button. The AgCam camera was working pretty well with a clear image and very little interference. And even though the operator had only been operating it for a couple of days when these trials were done, he was coming up to speed pretty quick. And he was impressed with the reduced workload that he was required to do because of the automation of the Skyline. Looking at the Grapple carriage, the picture on the left there is the original Grapple. So it was pretty big, the tines were large and appeared to be quite slow to open and close. So they were modified. It was decided that they'd make some changes, change the tines, and that's the picture on the right-hand side. You see the modification to the tines. The power to the grapple arms and the rotator function goes through a shaft in the hanging bracket, so there's actually no loose hoses at all when the carriage is operated, so there's no snagging or damage to hydraulic hoses. The other factor on the grapple carriage was the installation of a sensor for collision avoidance. That they found that in those initial trials that was mounted a bit too high on the carriage, and they wanted to relocate that. That's still to be done. And later on, the hydraulics in the grapple carriage were modified with a new valve bank for the carriage installed. So the major feature of the hydraulic Skyline is that semi-automated Skyline control, raising and lowering the Skyline to maximise the deflection during in-haul and to track the terrain. And this is really illustrated in this short video clip, which you'll be able to see the Skyline drum at the top there moving in and out without the operator control. So the tension is maintained within safe working load of the Skyline. You see it stops there and it's dropping out. And this is all done without the operator having to do anything. Outhaul is controlled, and in-haul on the main line is controlled directly by the operator. So let's look at a bit of an update since those initial trials. The hauler control software has been changed. Rosewater May have modified the hydraulics in the grapple carriage, as I mentioned, changed the claws on the grapple to make them a bit shorter. The tension monitoring system is working well, so no change has been done there. And while it's still in the commissioning phase, Rosewater May hosted a field demonstration to the project co-investors last week. So we'll just have a look at the grapple carriage operating. Short video clip here showing the carriage basically tracking along the terrain. And you can see that swinging arm where the grapple's connected to a drawbar which is directly connected to the sheaves, so any shock loading goes up into the sheaves and back along the skyline rather than any damage to the carriage. And back for another drag. So shotgunning here, but obviously you could be using a tow rope if required. So what are the next steps in development? Well, they want to obviously complete all the required modifications. I mentioned that skyline drum ratios to increase the speed. Integrating a machine vision system is the next big stage that FGR would like to see done. We've got a separate project going with a couple of technology developers looking at stem recognition for the next load. And in the future, developing automatic lowering of the skyline and positioning of the grapple, auto return to the landing, controlling the skyline tension and the ground clearance through that collision avoidance system, auto stop at the landing edge, lowering of the skyline and landing the load. And then you'd have automatic carriage return back to the breakout site. So as I mentioned at the start, this project has been a collaboration between Rosewarne May Limited as the technology developer, Hancock Forest Management and Rainier Matariki Forests, the two forestry companies contracted to Rosewarne Cable Loggers, and the Ministry for Primary Industries providing a large amount of the funding, and Forest Growers Research, which is supported by the Forest Growers Commodity Levy. So I guess the last word as far as collaboration really goes to Lars, the project instigator.
Yeah, like you say, they were on board and they wanted to see it happen. So, yeah, here it is.
Man, a few words. So he's pretty happy with it, and as he told the group at the field demonstration last week, there's obviously further developments to be done, and as he said, it just depends on how big the chequebook is to how much of that work we can continue to do. But Forest Growers Research is going to continue to support Rosewarne and May in this exciting development. So thanks very much.